Okay, welcome back to Calculus 2. So we are looking at finding the surface area of revolution of y is equal to the square root of 5 minus x. You don't have to graph this one, but what we're looking for is something like this. And here's my 5 minus x, and we're going to go from 3 to 5. And we are taking this little slip here, and we're rotating this whole little piece over here. So it's like a surface area of revolution here. Okay. So what is our formula? The surface area formula is equal to, I think it's going to be 2 pi because we're revolving, r times our little surface area times our ds. Okay. And we're going to integrate this between 3 and 5. Okay. So that's what we're dealing with that. Let's go ahead and say, what's my r? R is going to be from here to there. So my r is actually equal to y. So we have surface area is equal to 2 pi integral of y. And then we're going to have this 1 plus f prime of x squared, okay, as a square root in here, right? The same as the arc length area, dx. And we've got all of that to mess with, okay? So let's clean this up a little bit. So my surface area is equal to 2 pi integral, and we'll put the 3 and the 5 in there for a minute. Y, what the heck is y? Y is actually square root of 5 minus x. We're going to have square root of 5 minus x. Leave this alone for the time being. Times, and now we're going to need 1 plus f prime of x squared dx. And then there's a big square root out in front of this. Okay, so that's what we have. So let's go through the little pieces that we have to go through. We have to go through to figure this out. So f of x is equal to 5 minus x raised to the 1/2 power. So you turn it into a calculus problem there. F prime of x is equal to 1/2 5 minus x raised to the negative 1/2. Okay, so that's what we have for that piece. And then what we're going to do is we're going to square this thing. So we have f prime of x quantity squared. That's going to be 1 over 4 times 1 over 5 minus x, because this is a square root, and we're going to square it. Still on the bottom. Okay. And then the next thing we're going to do is we're going to add 1 to this. So let's go ahead and we've got this. We've got 1 over 4 times 1 over 5 minus x, right? That's the f of x squared, plus 1. And we're going to take the square root of this whole thing and multiply it by the outside stuff. Okay, square root of 5 minus x. Okay, we're going to integrate it after that. So let's go ahead and multiply this thing out. Okay, so we've got to add 1. So we've got 1 over 4, 5 minus x sitting here. Don't multiply this out just yet. Just hang on to that for a moment. Plus, and then we have to go ahead and figure out what's going to happen here. We've got 4 times 5 minus x over 4 times 5 minus x, right? And we're adding these guys together. Let me go ahead and make that a little bit more clear. Okay, so there we go with this. And we're adding. This is a fancy way to write 1. Now we're going to multiply this out. Okay, because this one we actually have to multiply out because we want to combine numerators. So we're going to say this is going to be 20 minus 4x plus 1 over 4, 5 minus x. Notice that these are all common denominators and we're allowed to do that. Okay, still, this is all inside of a square root. So let's go ahead and fix this up a little bit. So we have a square root. Now we have 20 plus 1, so we have 21 minus 4x all over 4, 5 minus x. And then on the outside, we have 5 minus x dx. And we're going from 3 to 5. Okay. So here's what's usually going to happen with these problems. Not always, but frequently, this is the thing that happens. If I have the square root of a over b, I could say that that's the square root of a over the square root of b. Right? That's one of those things that you get to learn about with how radicals work. So what I'm going to do is I'm going to say that this is the integral from 3 to 5, and I'm going to have the square root of 21 minus 4x times 1 over, take the square root of 4, we get 2 square root of 5 minus x. And what do we have also on the top here? We have the square root of 5 minus x. Hey, what do you know? By the way, there's a 2 pi out in front here. That's what we had. Okay, there's a kitty over here. And then dx. Well, some stuff cancels. Good news for a change. Some stuff cancels. Let's see. We have a 2 and a 2 cancels. So we have these 2 cancels. So we end up with pi. It's almost like somebody planned it this way. 3 to 5, and we have the square root of 21 minus 4x dx. That's almost a calculus 1 integral, right? That's the way it should be. Okay, sometimes they're kind of tricky and they're awful, but sometimes this just comes out to be really nice. Let's go ahead and let's set u equal to 21 minus 4x. So du is equal to negative 4 dx. I'm going to go ahead and stick a negative 4 here and a negative 4 there. So this piece here is now my du. So what I have, I'm going to do one more thing. I'm going to say when x is equal to 3, u is equal to 21 minus 12. Do you believe that is 9? Okay. When x is equal to 9, right, or 5 rather, not 9, 5. Okay. X is equal to 5. U is equal to 21 minus 20, 5 times 4, which is equal to 1. So now we are instead of the x's here, we now have u's. So I have negative pi over 4 integral from, let's see, we're going from 3 to 5. I have u to the 1/2 power du, because that's negative 4 dx was my whole du here. I'm going to do one more little bit of a trick here, and that's when you have a negative sign on the outside here, you can swap the order of integration. So I'm going to say this is going to be pi over 4. Why would you do that? Trust me, it's a little bit nicer. And we have 1 to 9, because I'm just used to writing low number to high number, and it makes me feel better. And then we have integral of u to the 1/2 power du. Notice they are all the same power. They're all the same variables, so we're all good. So this is going to be pi over 4 times u to the 3/2, divide by 3/2, which is going to be 2/3. Okay, some stuff cancels, so we're going to be able to do this. And we're going to say this is equal to, and we're going to go from what? 1 to 9. So this is going to cancel out a little bit. So we have 2 times 3, so we have pi over 6. That's a nice angle. Times, as the took out the 2/3, and we have 9 root 9 minus 1 root 1. That's a fancy way to write 3/2 power. Is the a to the 3/2 power is equal to a root a, right? We go ahead and do that. So that's, what is that going to do for us? That's going to be pi over 6 times, let's see, we have 9 times 3, that's going to be 27, minus 1. So we end up with 26 pi over 6. And then some of you guys don't reduce very well. If it's within your 12 by 12 little thing, please reduce it for me. So we end up with, this is 2 times 13. This is 2 times 3. So we can go ahead and cancel some stuff. So we have 13 pi over 3 square units, because we're figuring out a surface area of revolution. That's going to be my answer. Hopefully those are nicer problems for you, but what you want to do at the end is you always want to look for like this square root of a thing canceling with the square root of the other thing. That's frequently going to happen when you're working these types of problems. Okay, so look for those. Okay, I'm going to say thank you very much for watching the video. Good luck doing the problems. I'll see you next time, and take care.